Welcome to this explainer. Today, we're embarking on a deeply cinematic, forensic investigation into the dark, hostile voids of our solar system. We're going to uncover exactly what it would take to survive the extreme environments of every single planet and expose the silent, lethal mechanisms just waiting to destroy us.
So, let's start our journey by pushing outward from the sun. We're going to descend from scorching inferno straight into the crushing, pitch-black depths of the outer limits. Just imagine dropping into these alien atmospheres. What exactly is waiting for you out there in the shadows?
Section 1. The Inner Inferno, Mercury and Venus.
Starting with Mercury, our closest planet to the sun. You probably expect it to just be hot all the time, right? Well, a lack of a proper atmosphere, it basically just has a very thin exosphere, causes these wildly violent temperature swings. During the day, you are blasted with nearly 7 times the solar irradiance we get here on Earth, skyrocketing temperatures to a blistering 430 degrees Celsius. But at night, it plummets to an icy minus 180 degrees. To put that lethality into perspective, NASA's most advanced spacesuits can only handle between minus 157 and 121 degrees Celsius. So, stepping onto the surface, you would be instantly incinerated or frozen entirely solid. Honestly, your only hypothetical chance of landing among these rough craters and steep cliffs is a narrow strip known as the Terminator Zone. It's the shadowy boundary right between day and night. But even here, the rapid temperature shifts make it a massive, massive risk. And worse, Mercury's extremely low air resistance means that simply slowing down your ship would be incredibly difficult. You'd highly likely be looking at a catastrophic, high-speed crash directly into that bumpy, desolate terrain.
Moving outward, just a 4-month journey, or about 40 million kilometers away, sits Venus. Now, from orbit, it looks pretty serene, but it is hiding a deeply hostile environment beneath those beautiful yellow clouds. As you begin your descent, you'd quickly discover those clouds are actually made of highly corrosive sulfuric acid that would literally destroy your lungs in seconds.
And as you plunge further toward the surface, the light just vanishes. Only about 10% of sunlight even penetrates that suffocating carbon dioxide atmosphere. Down in the impenetrable gloom, you're facing a relentless 450 degrees Celsius. But you know what the true killer is here? A crushing 92 bars of atmospheric pressure. Moving your arms would feel like wading through heavy liquid. Before long, that staggering pressure, which is equivalent to the deep ocean right here on Earth, would completely crush your suit.
Section 2. The Deceptive Red Planet, Mars.
Mars kind of looks like a dusty desert you might find on Earth. And sure, daytime highs can hit a comfortable 20 degrees Celsius, but the deception absolutely ends there. At night, the temperature drops drastically to minus 13 degrees or even lower. Plus, you'd have to survive practically zero breathable air in its incredibly thin carbon dioxide atmosphere, all while being relentlessly battered by violent dust storms, with winds ripping across the surface at 100 kilometers per hour. The ultimate invisible threat on Mars? It's the natural radiation. Because there is almost no atmosphere for protection, radiation hits 24 to 30 rads. That is up to 50 times the average exposure on Earth. Escaping this unseen killer means any hope of survival out there requires a highly sustainable, completely airtight, and heavily insulated life support system. Section 3. Plunging into the giants, Jupiter and Saturn. Okay, assuming your hypothetical suit somehow saves you from the lethal radiation 300,000 kilometers out, your descent into Jupiter would be a terrifying, high-speed freefall under 2.4 times Earth's gravity. You'd drop into absolute darkness through freezing ammonia clouds at minus 150 degrees Celsius, getting battered by 482 kilometer per hour winds. Down past the 150 kilometer mark, which is exactly where the Galileo probe died in 1995, you'd eventually be swallowed by dense metallic hydrogen. It's a state so heavy it traps you long before you even hit a core that burns at an apocalyptic 24,000 degrees Celsius. That's roughly 4.5 times hotter than the surface of our sun. Deep in Jupiter's abyss, the environment completely breaks down the laws of physics as we know them. As you fall, you are swallowed by a supercritical fluid. It's this bizarre state of matter forced into existence by immense pressure. It's neither fully liquid nor fully gas, creating a dark, crushing environment completely unlike anything we can experience back on Earth. And just how immense is that pressure? The estimated force near Jupiter's center is a staggering 100 million times that of Earth's atmosphere at sea level. It is an unfathomable force that absolutely dominates the planet's terrifying abyssal interior. Next up is Saturn, To even enter its hydrogen and helium atmosphere, you first have to weave through a deadly obstacle course of 146 moons and rings made of shattered comets, asteroids, and ice pellets. If you manage to survive that, you'd hit the equator. Right here, beneath these stunning red and purple atmospheric auras, you'd be blasted by 1,800 km/h hurricane force winds. And if you try the North Pole instead, you drop straight into a massive, impenetrable storm so large you could fit 2 entire Earths inside of it. Descending through Saturn's dark atmospheric layers, the environment transitions drastically. You start out in bone-chilling ammonia clouds at -250 degrees Celsius, but as you sink deeper, gases compress into this ocean-like liquid pressure, and the cold gives way to an absolute inferno. You'd eventually meet a molten rocky core, 10 times the size of Earth, burning at 11,700 degrees Celsius. Again, more than twice as hot as the sun's surface.
Section 4. The frozen outer edge. Uranus and Neptune.
Let's move even deeper into the void, to Uranus. Now, ice giant does not mean a solid ball of ice. It means it's composed of heavier elements. This eerie world spins completely on its side with blistering 17-hour days. Any doomed visitor plunging past its own set of rings would be instantly surrounded by heavy toxic gases and the absolute coldest temperatures in the entire solar system, dropping well below -200 degrees Celsius. Passing deeper through Uranus's dense, dark air, you'd be aggressively pelted by ice. But then, you'd witness one of the most mesmerizing yet totally deadly phenomena in the cosmos, a rain of solid diamonds. Driven by 900 km/h winds under 100 times Earth's atmospheric pressure, these diamonds would literally shred through almost anything. Finally, we reach Neptune. Orbiting out in a near total void, this dark world sits a staggering 30 times farther from the Sun than Earth does. In a lot of ways, Neptune acts as Uranus's extreme shadowy twin, sitting at the absolute fringes of our reach. Neptune is truly a planet of hidden extremes. The outer layers are freezing and completely devoid of light, violently churned by supersonic winds, actually the strongest in the solar system. Yet, as you descend, the immense pressure actively breaks down atmospheric methane to create its own haunting diamond rain. This rain falls continuously toward a core that is intensely hot, burning at 7,000 degrees Celsius, once again a planetary core hotter than the surface of our own sun.
And that brings our explainer to a close. We've descended into acid clouds, been crushed by oceanic atmospheres, and witnessed diamonds raining down into the absolute abyss. With every single planet armed with lethal mechanisms perfectly engineered to destroy us, it leaves us with one provocative thought. As we look out into this beautiful, deeply hostile void, are we truly meant to conquer the solar system, or simply marvel at the miracle that we exist at all?